Many worlds interpretation of quantum mechanics, of the universal wave equation, and analysis of Hugh Everett III. Many worlds interpretation comprises of two assumptions and its consequences. The metaphysical assumption that the wave function does not merely encode all the information about an object, but has an observer-independent objective existence and actually is the object. And secondly, the physical assumption that the wave function obeys the empirically derived standard linear deterministic equation at all times. The observer plays no special role in the theory, and consequently there is no collapse of the wave function. Measurements and observations by the subject on an object are modulated by applying the wave equation to the joint subject-object system. A consequence is that each measurement causes a decomposition or decoherence of the universal wave function into non-interacting worlds and histories. The worlds and histories form a branching tree which encompasses all the possible outcomes of each interaction. The wave function is a real object, a relative state. Formulation predicts that the interactions between two or more macrosystems split the joint system into a superposition of products of relative states. If one of the systems is an observer and the interaction an observation, then the effect of the observation is split into itself, the observer into a number of copies of itself, each copy observing just one of the possible results of the measurement and unaware of the other results and all of its observer copies in the parallel universe that exists, notwithstanding that the wave function never collapses and the process of entanglement goes on for infinity. Interactions between systems and their environments, including communication between different observers, is in the same world. It transmits the correlations that include, however not limited to, the local splitting of decoherence in non-interfering branches of the universal wave function. Therefore, the entire world is split superluminally into a host of mutually unobservable but equal real world for infinity. The many worlds interpretation indicates that all possible outcomes of a quantum interaction are realized. The wave function, instead of collapsing at the moment of the observation, evolves deterministically to all possible outcomes of all possible existences simultaneously in a parallel universe that do not interfere with each other, each single prior world having split into mutually unobservable but equal real worlds. A world is a complex, causally connected, partial, complete closed set of interaction subsystems. The existence of the wave function contains observers themselves, in which any system, even the system of the universe, could be encompassed in a single, albeit intractable universal wave function. This breaks down to two fundamental components. The wave function obeys the standard linear Schrödinger wave equation that's deterministic at all times, and the wave function is physically real. The universal wave function is based on the concept and the idea that people, planets, stars, galaxies, even the entire universe could be a superposition of many states, just as the microscopic objects could. Therefore, multiple different versions of the universal multiple worlds could exist simultaneously, in which the universal wave function is coined the term multiple world interpretation of quantum mechanics. Therefore, many worlds is an extension of normal laws in quantum mechanics to simultaneous superposition from microscopic systems based on the nature of the observation, in which the macroscopic world can be a superposition of multiple states. For example, the observer and the system are independent, in which can get their joint wave function by multiplying together their individual wave functions, by which the two, after measurement, become entangled. That is, the state of the observer becomes dependent of the state of the system that was observed. The result is that for each eigenfunction in the system superposition, the observer's wave function evolves differently. Thus, we can no longer express their joint wave function as a product of the individual wave functions, and to express the joint wave function as the sum of the different components, one for each possible eigenfunction of the system that could be observed. Therefore, the different components are different worlds, with the only difference between them is being the eigenfunctions of the systems that was observed. If an observer in itself and the interactions that occur in that of itself with many systems, each in a superposition of multiple states, the distribution of states will follow the Born rule, we must assume that the basic wave mechanics is obeyed for all physical systems, including the observers from the phenomena of the wave function collapse, random measurements, and the Born rule of the apparent collapse of the wave function. Note that quantum mechanics is linear and eigenfunctions are orthogonal based on the principle of superposition decoherence is mathematically result following from the wave equation. That tightly interaction superpositions tend to evolve to non-interaction superpositions, and decoherence does not destroy the superposition. It merely diagonalizes it based on the angularity of orthogonality based on the eigenfunctions of the wave collapse. After decoherence, one is left with a superposition of multiple states, and the only way to remove the superposition is to assume the wave function collapse, which with multiple worlds has been shown to implicitly assume, therefore, if one accepts the universal applicability of the wave function, one must accept the multiple worlds it implies. For example, Feynman's observation that the amplitude of any given final state can be calculated as the sum of the amplitude along with all possible paths to this state. Thus, it is not possible to describe the state of the universe as a single history, since other parallel histories can interfere and change how the state will later evolve. The path of formulation integral infinity, for example, is the theory of the universal path integral of the universal wave function in its equation. Many worlds is a deterministic theory, since the wave functions obeys the deterministic wave equation at all times. All possible outcomes of a measurement or interaction are embedded within the universal wave function, although each observer is split by each observation is only aware of the single outcomes due to the linearity of the wave equation. The world appears indeterministic with the usual probabilistic collapse of the wave function, but at the objective level, in which includes all outcomes, determinism is restored. In cross-parallel to Everett's is Feynman's sum over histories. The sum over histories are path integral formalism of quantum mechanics, which indicates that the path integral picture of the wave function of a single particle x is built up of contributions of all possible paths from x, where each path contribution is weighed by a phase factor of exponent wave function at x is summed in turn over all values of x. The action path is the time integral of the Lagrangian kinetic potential energy on the path from x1 to x2. The final expression is thus the sum or integral over all paths, irrespective of any classical dynamical restraints. In the path integral approach, every possible path through configuration space makes a contribution to the transition amplitude. From the point of view, the particle explores every possible intermediate configuration between specific start and end states, therefore the sum over all histories. The two processes are false. Process 1, discontinuous change brought about by the observation of a quantity with eigenstate in which the state function will change to the state function with the probability of the state function and the composite system. And process 2, the continuous deterministic change of the state of the isolated system with time according to the wave equation, where U is a linear operator. The analysis to and therefore the search of the hidden variable is a necessity to the validity of the theory of the universal wave function, which presents us with alternative 5, process 2. Alternative 5, to assume the universal validity of the quantum description by the complete abandonment of process 1, the general validity of pure wave mechanics without any statistical assertion is assumed for all physical systems, including observers and measuring apparatus. Observation process should be described completely by the state function of the composite system, which includes the observer and his or her object system at which all times obeys the wave equation, vis-a-vis process 2. The former is indicative to the latter effect, in which universal validity of the state function description is asserted. One can regard the state functions themselves as the fundamental entities, and one can even consider the state function of the whole universe. Therefore, if the total information is constant, the total entropy is also constant. The system at any instant is represented by a point in the phase space of all positions and momentum coordinates. The natural motion of the system then carries each point into another, defining a continuous transformation of the phase space into itself. Therefore, if one were to define the total entropy to be a negative of the total information, one could replace the second law of thermodynamics, vis-a-vis, for every action there is the opposite equal reaction, per se, in which energy is neither created nor destroyed, yet transferred. While it's conceivable that some outside agency could reverse the total wave function, I believe that the change of the reverse total wave function can also be brought about by the observer, vis-a-vis consciousness, to the object system of his or her own will, is therefore to become a time traveler, a parallel multiple worlds in level 3 multiverse.